Welcome back to this video series of C++ programming. This is the lecture 15 of this video series, and today we are going to discuss about references in C++. It is one of the very important topic of C++ programming. References is a C++ feature which is related to a pointers. Reference is essentially an implicit pointer. So we'll talk about this implicit pointer, how references are used as an implicit pointer in this video as we progress further. There are three ways that references can be used. First, as a function parameter, when you pass the parameter to a function and when you return any value from function, and third, as a standalone reference, that is as a variable. So variable can be used as a references. Now, as you know, the arguments can be passed to a function by two different ways. One by using a call by value and another by call by reference. When you're using the call by value, the copy of that argument is passed to a function. So the new variable or the new object is created when you use the call by value, and that object is created temporarily onto a stack. And when you exit that function, that object is destroyed. In call by reference, the address of the argument is passed to a function, and then it is collected as a pointer. By default, C++ uses call by value, but it provides two ways to achieve the call by reference parameter passing. First, using an explicit pointer to the argument, as we discussed in this second point, and second is using the reference parameter. And in this video, we'll talk about the reference parameters. Now let's understand the references with the help of example. First, we'll see how to swap the two variables with the references, and in the second example we'll see how we can pass the references to objects. So let's get started. First, I will create one class and I will call this as my class. Now inside this we'll create one function that will swap the data, and I will create two variables which are of integer types, and we'll swap the values of these two variables. Now all these elements are public to this class, so they can be accessed outside the class. Here inside the main function, I'll create object for this class. First, we'll initialize this data members to some values. Say data1 is holding the value as 30 and data2 will hold the value, say 40. And now with this object, we'll call this swap data function to swap these values. So our purpose is to swap this data1 and data2 elements using this swap data function. Now, as we know, there are two ways the values can be, three ways actually the values can be passed to a function. One is by directly passing the values, and then here creating the temporary variables, and then passing the address of these variables and collecting as a pointer, and third using the references. Now with the first way, by passing the values, the swapping cannot happen, but by passing the address and collecting as a pointer, then we can swap the values. In this example, we'll see how to swap the values with the references. First we'll see how to use the references. So here we are passing, when you are using the references, you have to just pass that data element or member variable, and here you have to specify this data type ampersand operator and the variable name. So now this value 1 is one references, and now it is pointing to this data1 member variable. Similarly, we'll create another reference variable. So now these two are the reference variables. Let's add them in the prototype as well. When you use the reference, you don't have to specify the ampersand operator here. We're actually specifying the ampersand operator at this place, which is unlike to your normal pointers. And now this references now becomes an implicit pointer. Remember, they become an implicit pointer which points to this data members which are passed as an argument in this calling function. And now with this implicit pointers, we can access this data elements. So here now, if you want to modify the value of data 1, if you add the statement value 1 is equal to 40, now it will actually modify the value of this data 1 variable here, because now this is acting as an implicit pointer to this member variable. Now let's see how we can swap these two values. First I'll create one temporary variable. Now we'll first get the value 1, and that is the value of this data 1 variable into this temporary variable. Then we'll assign the value 1 variable with the value 2 variable. At this stage we are actually copying this data 2 value into a data 1 value, but here we already have set the data 1 value here. And in the next step we'll copy this temp variable into this value 2. Now this value 2 is pointing to this data 2, and this temp 1 was holding the value 1, which is a data 1. So now data 1 is copied into this data 2 in this third statement, and here data 2 is copied in data 1. So if you observe carefully, unlike the pointers, you don't have to mention this asterisk operator here, because these are the implicit pointer as we talked. So you have to just mention the variable name, because now they are acting as references. Now we'll print this data 1 member variables, the values of this data 1 and data 2 here, so that we'll get to know whether they are swapped or not. Let's run the program and let's see what does it outputs. So it is outputting the first value as 40 and second as a 30. So that means it has swapped the values. So we saw how the references can be used in the programs. The references can be returned from a function. We'll see one example how to return the references from a function. So for that purpose, I will create one array of character. I'll call this as a str, and I'll store the string as hello there in this character array. Now here I will create another function, call this as a replace. So here I want to insert some character in between this two words. So there is one space here. So in between we want to insert one character. So for that purpose we'll use this function. Now we want to return the references from this function. So this return type must be of a reference. So this is the type of this variable which we are returning, and this is a address. That means it is returning as a reference. Now here, with help of object, we'll call this replace function. Now this 5 indicates the uh, space. I mean, this is just index to this string. So this 5 will point to this empty space here. So I'm passing this 5 value here, and in this replace function we'll collect the parameter as the index. I move this string here at the start of this function, and here I'll return the So I've written this str which is indexing to the fifth element, and now that is collected as a reference variable. And here we initialize this x variable here. So what we are doing here is basically at this index fifth of the this string array, we are placing this character x. So let's print the output of str here. And let's compile a program now. So now it is printing the value output as hello x there. So this is how the references can be written from a function. Now let's see the second example, how to pass the references to an object. Now in this case we have used the references for the variables. Similar to variables, the references can be used with the objects. Now I will add one more function here, and I will call this as a negate. So this function will actually negate the value of the number, and inside this we'll we'll create the reference to an object. But before that, we'll add this function outside this class. And from here we'll call this negate function, and now here we'll pass the object as a parameter. When you pass the object as a parameter and when you want to collect this as a reference, you have to specify this type of that object, and then ampersand operator, and then the name of object. So this can be of your choice. So similar to variable, the references are used with the objects. And now with these objects, we can access the member variables of this class. So in this case, we'll negate this data1 member variable using this object reference. So observe carefully, we are using this dot operator. Even though now this is acting as an implicit pointer to this object, we are using the dot operator to access the member elements. We are not using this arrow operator. The reason is arrow operator is not applicable to the references. It is used only for the normal pointers. And now let's print the value of data1 variable here. So it is outputting the value as -30 for data1 variable. So we saw how to pass the references to an object. And the references can be used as independent references. So this is the third point we talked. Three ways the references can be used, and they are used as a standalone references, or they are called as independent references. So you can declare a references that is simply a variable. This type of reference is called as an independent reference. When you create an independent reference, all you are creating is another name for an object or a variable. So basically this is another name you're creating for any particular variable. All independent references must be initialized when they are created. When you create a reference, you must initialize, and later on you cannot initialize them. You cannot change what object a reference variable points to. Therefore, it must be initialized when it is declared. So as we talked just now. Now now this independent references are just another name for the one variable which is already existing. So they are quite rarely used in the C++ programming. But let's understand about the independent references with the help of an example. In this main function, we'll create one variable. We'll call this as a variable 1. And now we'll create one reference variable and we'll call this as a R variable 1. Now this is an independent reference variable, and as we talked, we have to initialize this reference variable as soon as we create it. So how to initialize it? We have to just mention this variable 1. Now this acts as a reference variable and which is pointing to this variable 1. So basically this is another name. This R variable 1 is another name for this variable 1. And now we'll see what kind of different operations we can perform with this reference variable. So if I define this value of this variable here 20, and if you print the R value, when you print this R value and R variable 1 and variable 1, it must output the same value, that is a 20. So it is outputting the value, both value as 20. That means this both variables are now the same, and this is just a reference to this another variable. When you use this statement, that is you are assigning the value to this reference variable 1. When you do this, you're actually assigning the value to this variable 1. So if you try to print this same statement again, that's the value of this R variable 1 and variable 1, you should print the output as 100. So it is printing the values as 100. And if you create another variable, suppose variable 2, and you're assigning some value as a 40, and here if you assign this variable to this reference variable, then we are not actually modifying the address of this our variable 1 reference. We are actually assigning this value of variable 2 to this variable 1. So if you print the this variable 1 value again, it should print the output as a 40, as you can see here. And if I perform some arithmetic operations here, so if I decrement this R variable, so this is actually decrementing this value of this variable 1 by 1. So if you print here this variable 1 and R variable 1, it should print the output as 19 or 39, because earlier we have assigned a value as a 40 to this variable 1. So we saw how these independent references are used. And finally, let's talk about the restrictions that are applied to the references in C++. First, you cannot reference another reference, meaning you cannot obtain the address of a references. You cannot create array of references. You cannot create a pointer to a reference. Also, you cannot reference a bit field element. A reference variable must be initialized when it is declared unless it is a member of a class, a function parameter, or a return value, as we talked before. And the null references are prohibited. So there are many restrictions applied on the references. But references are very useful when you are passing the objects or a variable to a function. So when you pass the objects, another copy of that object is created and that is stored onto a stack. So that unnecessarily wastes the memory. So to avoid that, these references can be used. And when you pass the object to a reference, so in this case, when you pass the object to a reference, the another copy of this object is not created. So this is just an implicit pointer to that an object. So when you exit this function, the destructor function is not called because the object is not created. It is just act as a pointer. So in the scenario where passing the objects of a smaller size and you want to save the stack space or the amount of processing time that is required in pushing and popping the content onto the stack, you can use the references. So this is all from this video. Thanks for watching it and stay tuned for the upcoming videos.